Hello my schoolers, I'm Abiola and this is my school channel where we are tackling the 2018 JAMB past question for chemistry. In this clip we'll be solving questions number 1 to number 22. So join me as we tackle question number 1. A given amount of gas occupies 10.0 dm cube at 4 atmospheric pressure, okay, ATM, and 273 degrees Celsius. The number of moles of the gas present is, given the molar volume of gas at standard temperature and pressure, equals 22.4 dm cube. So we are asked to find the number of moles of the gas present. So remember the ideal gas equation, which is pressure times volume equals the number of moles, okay, times the ideal gas constant and temperature in Kelvin. Remember the temperature we are given is 273 degrees Celsius. Bringing it to Kelvin, we add up to 73, okay, and that gives us, when we add it up, that gives us 546 Kelvin. All right, so let's pull out our given data. So for our given data, we are given temperature already as 546 Kelvin, okay? We are given the pressure as 4, pressure equals 4 atm, atmospheric pressure, okay? Then we are given volume as what? From the question we are given volume as 10.0 dm cube, okay? Then we've gotten our pressure, we've gotten our volume, we have temperature. Then we have our R, which is the ideal gas constant, and that is 0.082, okay? So we are asked to look for the number of moles. Very well. So let's plot this into our equation and derive our answer, okay? So recall that we are asked to look for N. So what do? Divide both sides by RT. Okay, so that implies N equals PV over RT, okay? Given our P as 4, our volume is 10 over our ideal gas constant, which is 0.082, okay? Times our temperature, which is 546. Okay, so when we divide through 40 divided by what we have in the denominator, you should arrive around roughly 0.89. Remember the unit for moles is mol, okay? So this should be our answer. So when we scan through our options together, option A is very correct. So we have question number 2. According to Charles' law, the volume of a gas becomes 0 at what temperature? Okay, so it becomes 0 at temperature of minus 273.15 degrees Celsius, or according to Gay-Lussac's constant, it can be minus 266.66 degrees Celsius. So fitting with the options that we have here, so we can say, according to Charles' law, the volume of a gas becomes 0 at minus 273 degrees Celsius. So option C is very correct. So we have question number 3. A substance that is used as a ripening agent for fruits is what? Okay, it's actually ethane. It's a natural plant hormone that is responsible for flowering and fruit ripening. For artificial use, they most commonly use calcium carbide, okay? And sometimes they use some unsaturated hydrocarbons like acetylene and ethylene. So for the context of the question we are given, a substance that is used as a ripening agent for fruits is option A, ethane. Option A is very correct. Remember that you need to join the winning team of my schoolers that have downloaded the Myschool mobile app or purchased the Myschool software in order to help them prepare better for their upcoming exams. So you can use the link I have provided you in the description below. That takes you to the Myschool website where you'll be given further instructions on how to get any of these tools. So join me as we tackle question number 4. The sulfide, which is insoluble in dilute hydrochloric acid, is what? It's actually copper sulfide, because iron sulfide, zinc sulfide, and sodium sulfide, they are soluble in HCl to produce their metallic salts, okay, and also to give out hydrogen sulfide gas, okay. So scanning through our options, and for emphasis sake, only copper sulfide in this context is insoluble in HCl acid. So that makes option B very correct. So, you just have to hit the like button, click on the subscribe button, and tap on bell notifications so you can get updated as soon as we release the next videos. Question 5. What is the pH of 0.001 mole per dm cube solution of the sodium hydroxide? So this is very simple. Just use the simple formula, which is POH, okay, equals minus log of this, okay. So we are given from the question that this is 0.001. All right, so if we bring this to its standard form, this is just a 1, 2, 3. So this makes minus log into bracket 10 raised to power minus 3, or 1 times 10 raised to power minus 3. That's just it, okay? So this still implies, okay? Remember how we work on our log? We have this minus here, then this 3 comes here, minus 3, okay, into bracket log 10. This is already base 10. Raised to power this 10 here, okay. This is just very relative to how we solve logarithm questions in mathematics, okay. So we would have here minus times minus will have plus, so that is 3 times log 10 base 10, that is 1, so 3 times 1 is still 3, so the POH is 3. Then recall that the pH plus POH equals 14 on the scale, isn't it? So pH, we're asked to find the pH, will be equals to 14. When this comes out, it becomes minus. What's the value of the pH that we have gotten? We got it as 3 minus 3. So on the pH scale, the answer is 11. Okay, so let's go through our options together and realize that option D is very correct. So we have question number 6. Okay, so the type of bonding in this is what? At first, this is a tetramine copper 2 ion, okay? So this is just it. So the type of bonding here is a coordinate covalent bonding, coordinate, option A. Why is it that? Because you see this is a ligand and this is a hell ligand, which is neutral, okay? What is a ligand, you may ask? A ligand is an ion or a molecule that donates electrons to the central atom here. So putting all of this together, you just see that this forms a coordinate covalent bond, or a dative covalent bond, okay? So in summary of everything, option A is correct. This is a coordinate type of bond. So we have question number 7. Which of the following is an example of a chemical change, okay? So we have physical change. Physical changes are types of reaction that are easily reversible, okay, and no new products are usually formed. While chemical change is a complete opposite. At first, it's an irreversible reaction and new products are usually formed. So let's go through the options together and see which of them is an example of chemical change. So the solution of salt in water, when you dissolve salt in water, okay, the salt disappears and you just see a clear water solution, but on heating the water to evaporation to dryness, you will still find your crystals of salt back again. So this is a reversible physical reaction. Okay, rusting of iron, this is definitely a chemical reaction because new set of compounds are being formed from the reaction, okay, and you can't get your whole iron item or material back again. Melting of ice, once you melt ice, taking it back to the freezer or refrigerator, you get your ice back. Separating a mixture by distillation, fractional distillation, you can still bring them back together, okay? So Of the options we've considered, option B is a chemical change, which is irreversible. So rusting of iron is correct. Option B is very correct. I believe you may have one or two questions you'd like to ask and get more clarity. Okay, so you can use the link I have provided you in the description below that takes you to the Myschool website where our solution providers are waiting to help you out. So join me as we tackle question number 8. To what temperature must a gas at 273 Kelvin be heated in order to double both its volume and pressure? So join me as we go to our whiteboard where we provide solutions to questions given to us. So we are asked to what temperature. So if we try to scan out our given data, we realize that, okay, that to what temperature, that is T2 is unknown. We are given T1 as 273, okay, and we are told that the pressure P1, let's say P1 is just 1, okay, and V1, let's just take it as 1 also, 1 atm, okay, and 1 dm cube, okay, very well. So, and the question requires that to what temperature must a gas at 273 Kelvin be heated in order to double its volume and pressure? So that is to double its volume, that means V2 will be times 2 of V1, that is 2 dm cube, and pressure, so P2 will be times 2 of P1, that is 2 atm. So let's just fix this in and we are going to get the temperature. Okay, so recall that P1 V1 over T1 equals P2 V2 over T2. So we are asked to find T2. So when we cross multiply, we would have T2 into brackets P1 V1 equals P2 V2, okay, times T1, dividing both sides by P1 V1. Okay, this strikes out P1 V1. Okay, so finding our T2, what we're going to have is this formula here. So we have T2 equals P2, which is 2, times V2, which is also 2. Okay, sorry, that's a repetition. Okay, times T1, which is 273. Over P1, which is 1, V1, which is 1, okay? So, when we multiply, going by the question says, at what temperature must a gas at 273 Kelvin be heated? So, we are looking for the T2, which is what we are trying to produce here. So, when we multiply all of this together at the top, 2 times 2 times 273, we are going to have 102 over 1 times 1, that is 1, and that gives you 1092, rather, temperature in Kelvin. So the temperature we are to raise it to, or that the gas must be heated to, is 1092 Kelvin. So that makes option D very correct. Perhaps you have better solutions or explanations to any of the questions we'll be making or we've solved so far. Please use the comment section below, indicate the question number and the solutions you would like to share. Question number 9. According to the kinetic theory, an increase in temperature causes the kinetic energy of the particles to increase. Okay, so they are going to gain more kinetic energy and there will be more collision between the particles. Okay, if you, even in solid states, it helps the particles to break the bond that is keeping them together. Even in liquids too, that's why when you are boiling water, you see that particles that have gotten or increased their kinetic energy through it, they will move up. The others that haven't gotten will go down. Okay, and there goes on the process until enough energy, kinetic energy, is gotten and some turns into steam or vapor. Okay, so in summary, according to kinetic theory, an increase in temperature causes the kinetic energy of the particles to increase. So that makes option B very correct. Question number 10. The element used in the production of matches is what? Okay, so normally sulfur fillers, glass powders, okay, they are being mixed with some oxidizing agents like potassium chlorate and what have you. That is the head of the match. Then the rest of the body, the rest of the stick, that striking stick, okay, is dipped into wax to enhance bonding, okay, while the side of the match box where we strike or lit fire from is made up from red phosphorus. We have other things like powder, glass, and what have you. So basically, in the context of our question, the elements used in the production of matches is sulfur, option D. Question 11. Which of the following gases may not be dried with concentrated sulfuric acid? So generally, acidic gases can be dried with sulfuric acid, like hydrogen sulfide, sodium dioxide, we have chloric gas. Why this ammonia gas rather is basic in nature? What it does is it combines with sulfuric acid to form ammonium sulfate. So definitely you can't dry ammonia gas with concentrated sulfuric acid, okay, because it's going to form a compound entirely ammonium sulfate. So it's because it is a basic gas. All of these other options, they are acidic gas. So option B is very correct. Question number 12. The consecutive members of an alkane homologous series differ by what? Okay, at first their general molecular formula is CnH2n plus 2. Okay, so where the first one is methane, CH4, the next is ethane, which is C2H6. So when you look at it, the difference there is CH2. So their members differ by CH2, making option B very correct. Question number 13. A correct electrochemical series can be obtained from sodium, calcium, aluminium, magnesium, zinc, iron, lead, hydrogen, copper, mercury, gold, silver, gold by interchanging what? At first, an electrochemical series, also known as activity series, is just the arrangement of elements, metallic elements in this context, okay, according to their increasing electrode potential when compared to hydrogen, okay. So when we look at this series, there is a kind of imbalance somewhere, and that is between aluminium and magnesium, okay. This is +3 and this is +2. This is +2 here, okay. So it ought to be magnesium before aluminium, okay. So where the adjustment has to be made is in option A, between aluminium and magnesium. So option A is very correct. So do not forget that you can either purchase the Myschool mobile app or get the Myschool software using the link I have provided you in the description below. That takes you to the Myschool website where you'll be given further information to get any of these tools. So we are tackling question number 14. A basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. This implies that what? Okay. At first, the kinetic theory of gases was postulated by the British scientists James Clerk Maxwell and also the Austrian physics. We have Ludwig Boltzmann, okay, in the 19th century, and they gave several theories or some of them which I'm going to share right now. At first, that these gases are made up of tiny particles called molecules, okay, and these molecules, they are in constant rapid straight line motion, okay, and when they collide, the collision is elastic, that is, there's no exchange of energy and there's no force of repulsion or attraction between them, and each of these molecules, they have distinct velocity, that is, their velocities differ, okay. So using the theories I've just shared with us, scanning through the option in context of the question, so we can say that a basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. This implies that the collisions are perfectly elastic. Option A is very correct. So do not forget to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as the next videos are released just for you. Question 15. On which of the following is the solubility of a gaseous substance dependent? Okay, so at first we have to consider the options we are given. Okay, we have high, that is 1, 2, 3 and 4, 1 and 2 only, 2 only, 2 and 3 only. Okay, so we're going to recall Henry's law that states that the solubility of a gas, okay, is directly proportional to the pressure of the gas above the solution surface or the surface of the solution. This simply implies that increase in pressure increases the solubility of a gas. That is why the soft drinks we take, for instance your Coca-Cola, okay, once you open the crown, you see that the pressure is being released and the gas, you see a gas that is evolved. So increase in pressure increases solubility. On the reverse side, when you talk about temperature, when you increase the temperature of a gaseous substance, okay, it decreases the solubility because the particles gain more kinetic energy and they can escape into the surroundings. So, considering the context of the options we are given, option D is very correct. Temperature and pressure are the factors on which the solubility of a gaseous substance depends on. So, option D is very correct. Question number 16. Which of the following statements is correct about the periodic table? So let's look at statement A or option A, okay? Elements in the same period have the same number of valence electrons. That is very wrong. Elements in the same period, they have the same number of shells, okay? Option B, the valence electrons of the elements in the same period increase progressively across the period. This is very correct because, for instance, if we take period 3, okay, so at the beginning of the period we have sodium, which has valence electron of 1. Then we have magnesium, which has valence electron of 2, followed by aluminium, which has valence electron of 3. So we can confirm that the valence electrons of the elements in the same period increase progressively across the period, okay? Option C, elements in the same group have the same number of electron shell. That is wrong. Elements in the same group have the same number of valence electrons. So, looking at it in summary, option B is very correct. Question 17. The periodic classification is an arrangement of the elements according to their atomic number. That is what the periodic table, the modern periodic table, is being built on. So elements are arranged according to their atomic number. So option D is very correct. Please remember that the link in the description below takes you to the Myschool website where solution providers are waiting for you to ask your questions right now. We are tackling question number 18. If 1 liter of 2.2 m of sulfuric acid is poured into the bucket containing 10 liters of water and the resulting solution mixed thoroughly, the resulting sulfuric acid concentration will be what? So we're just going to employ this simple formula on molarity C1V1 equals to C2V2, okay, where C1 is concentration of the acid and that is 1 times that is 2.2 rather from the question times the volume of the acid, which is 1 liter, equals the concentration of the resulting acid, which is C2, times the volume of the mixture. You know, readily we have 1 liter of water, 1 liter of the acid added to 1 liter of water. That gives you 11 liter in all. Okay, so dividing both sides by 11. So we have C2 will be equals to 2.2 times 1. That still gives you 2.2 divided by 11. So that is equals to 0.2. the molar concentration. So the molar concentration of the resulting acid is 0.2, and that makes option C very correct. Perhaps you have gone through our video clips and you would like to share one or two suggestions with us, as you have always done. Please use the comment section below to share your suggestion, or perhaps you want to solve one or two questions or relate better steps to us. You can still use the comment section below, indicate the question number and the solutions you would like to share. Question number 19. Okay, so in the shown experiment, which is this, the litmus paper will initially turn what? Okay, so at first we are heating the solute, solid ammonium chloride, okay, that contains ammonia and hydrochloric acid. That's the combination. So on heating them at 350 degrees Celsius, okay, the first gas that will diffuse up is the ammonia gas, because it has a lower molecular gas compared to the hydrochloric components of this. Okay, so the ammonia gas, when it diffuses up, when it comes up and hits the litmus paper, is going to turn it blue, because you know ammonia is a basic gas which turns red litmus paper blue. Then afterwards the hydrochloric gas is being evolved, which now turns the blue litmus paper red, because it is an acidic gas. So in summary, initially the litmus paper will turn blue because it is first attacked by the lower molecular mass of ammonia gas. So option D is very correct. So we have question number 20. The boiling of fat and aqueous caustic soda is referred to as saponification. You know, that is the process of converting fats or oil or lipids into soaps and alcohol by heating them in the presence of aqueous alkali like this caustic soda. Okay, so that is for saponification. While for hydrolysis, like hydrolysis of starch, that is breaking down a polymer into monomer. This is very relatable when it comes to digestion of food in our body. Esterification is the forming of esters when alkanoic acid and alkanols combine together. Okay, while acidification is when the content probably of the soil or of the ocean, okay, becomes more acidic for the soil. This happens when for instance, probably leaves fall from the tree, from a deciduous tree, and hydrogen ions are being released, okay, anions are being released due to the decomposition of these leaves, okay. Then for ocean acidification, that is probably when the carbon dioxide in the atmosphere gets dissolved in the water, so it increases the acidic level of water. So basically saponification is the formation of soap from fats, boiling fats in the presence of aqueous alkali. So option D is very correct. So question 21. Which of the following pairs of substances will react further with oxygen to form a higher oxide? So when you scan through all of our options, definitely this is out. Option A is out. This is nitrogen oxide, nitric oxide, okay? Because of water, it is out, okay? Then we have this carbon monoxide, should have been considered, but already this disqualifies the option. So we have sulfur dioxide, it reacts with oxygen to form sulfur trioxide in a reversible reaction, and we have nitric oxide reacting with oxygen to form the higher oxide known as nitrogen dioxide. So option D is very correct. Question 22. In the preparation of oxygen by the heating of potassium chlorate, okay, in the presence of manganese oxide, only moderate heat is needed because the catalyst acts by increasing the rates of the reaction around 1073 times. Okay, it's increased the reaction around 1073 times compared to when the reaction is not catalyzed at all. Okay, and this reaction gives you potassium chloride and oxygen gas is given off. So scanning through all of our options, option C is very correct. So don't forget that this is the end of this segment, but there's definitely more to come. and I know you are enjoying this sort of content and you want us to bring you more of them, please you just have to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as we release the next videos.